In section 7.4, we start looking at special right triangles. The first special right triangle that we will look at are 45, 45, 90 degree triangles. So first we have a theorem. This is called the 45, 45, 90 triangle theorem. In a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times as long as each leg. So this formula, hypotenuse equals leg times the square root of 2, is something I would definitely write down on my notes and highlight, star, whatever you need to do to come back to it. So again, if you know what one of the legs is, you would just take that number times the square root of 2, and that's automatically the length of the hypotenuse. Also notice if I have a 45, 45, 90, if these two angles are the same, that means that these two sides are the same, meaning it's an isosceles triangle. So as long as you know one of these, then you know the other one and the hypotenuse. You could also work backwards. If you know what the hypotenuse is in a 45, 45, 90, you could divide by the square root of 2 and get the length of each leg. We'll see this in the following examples. So here's example number 1. Find the length of the hypotenuse. So here's part A. So they give us in part A that the leg is 12 and we have a 45 degree angle. If it's 45 here and 90 here, it has to be 45 here. So again, we have a 45, 45, 90 triangle. So again, the leg is 12, so that means that this leg is also 12, and we would know that the hypotenuse, the side that is longest and that is opposite the right angle, is the length of the leg times the square root of 2. So in this case, the hypotenuse is 12 times the square root of 2. For part B, we have 10 square root of 2 and 10 square root of 2 for both legs. So since both legs are the same, that means I have an isosceles triangle, which tells me that the base angles are the same, which means that these are 45, 45, and 90. So again, I have a 45, 45, 90 degree triangle. So if one of the legs is 10 square root of 2, I know that the hypotenuse is the length of the leg times the square root of 2. So again, the hypotenuse is the leg times the square root of 2. It helps to write out that formula from the previous slide as you work through these. So the hypotenuse would be equal to the leg, which is 10 square root of 2, times the square root of 2. So we're going to multiply things that are alike. The square root of 2 times the square root of 2 is 2. So then the hypotenuse would be 20. Again, writing out the formula first helps you wrap your mind around what exactly you need to do and what you have and what you need to find out. So again, I encourage you to write out the formulas as you work through these. So now in this example, we're going to work backwards. So here's example number 2. It says find the length of the legs in the triangle. So notice we were given the hypotenuse this time. But first, let's identify what type of triangle I have. If I have a leg length of x and a leg length of x, that means I have an isosceles triangle, which means that this angle will be congruent to this angle, and if this is 90 degrees, it means I have a 45, 45, 90. So again, if you start off with that formula that the hypotenuse is equal to a leg times the square root of 2, we know that the hypotenuse is 15 square root of 2, and the leg is x. So I just need to get x by itself. So I would divide by the square root of 2. Those are going to cancel, leaving me with x equals 15. You could have just done this in your head, knowing that the hypotenuse is the length of the leg times the square root of 2. You could have just dropped that square root of 2 off, knowing then that both legs would equal 15. And now on to example number 3. Triangle MNP is a right triangle. Find the length of MP, which is this right here. So notice if this is 45 and this is 90, that means that this is 45, and 18 is a leg. So we know that the hypotenuse is the leg times the square root of 2. So the hypotenuse in this case is what I'm looking for. So it'd be 18 times the square root of 2, which that's as far as I can break it down. So the hypotenuse in this case is 18 square root of 2. So that's a look at the 45, 45, 90s. Now we're on to our second special right triangle, which are 30, 60, 90 triangles. So here's theorem 7.9, 30, 60, 90 degree triangle theorem. And a 30, 60, 90 degree triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So everything is based off of the shorter leg. Thinking back to the triangle theorems that we had about the shorter sides being across from the smaller angles, The shorter side is always going to be across from the 30 degree. The longer leg is always going to be across from the 60-degree angle, and the hypotenuse, of course, is always going to be the longest side. So if I know what the shorter leg is, again, that's the side across from the 30, the shorter leg times 2 gives me the hypotenuse, and the shorter leg times the square root of 3 gives me the length of the longer leg. Again, here are your formulas that you're going to want to refer to as you're going through this. So I would write these formulas down for sure, highlight them, star them, whatever you need to do so that you know these going forward, just like you did with the hypotenuse equals the leg times the square root of 2 for the 45, 45, 90. So again, write these down and star them, put some flags next to it, whatever you need to do so that you can refer back to these as you do your homework. So now we're on to example number 4. They want us to find the height of this triangle. So remember, the height is the same as the altitude. So first we need to recognize that we actually have an equilateral triangle, since this is 4, 4, and 4. An equilateral triangle is also an equiangular triangle, so that means that each angle is the same. Knowing that 180 divided by 3 is 60, each angle is 60 degrees. So when I drop an altitude down, I also know from previous chapters that an altitude of an isosceles triangle, which in this case it would be isosceles since it's equilateral, I know that the altitude bisects the angle up here. So when I take this right triangle out, so I'm just drawing this right triangle here, now down here, I know that this is 90 degrees right here. I know that this is 60 since it was equilateral. And since I also know that an altitude would bisect the angle, I know that this is 30. So putting in the values I know that that is 2 units and this is 4 units. So I'm going to look at what I need to find. I need to find this height, since this length right here is the same as this length right here. So looking at our 30, 60, 90 right triangle now, I see that the side opposite the 30, which would be my shorter leg, is 2, and the side opposite the right angle is 4. I do know that in a 30, 60, 90, the hypotenuse is always 2 times the shorter leg. So 2 times 2 is 4, so that is accurate. I also know that the longer leg, which in this case would be across from the 60 and the side that I'm trying to find, the longer leg is always the shorter leg times the square root of 3. So again, it's the longer leg that I'm looking for, which we're calling h, is the shorter leg, which we know is 2 times the square root of 3. So therefore, since the longer leg is 2 square root of 3, that means the height of this isosceles or equilateral triangle is 2 square root of 3. So again, I just used my theorem about 30, 60, 90s in order to solve that. So now we're on to example number 5. Find A and B, write your answer in simplest radical form. So that just means no decimals, and we want to break it down as far as we can. So the first thing I notice is that I have a 30, 60, 90 degree right triangle. I also notice that I was given this side length of 15, which is across from the 60. So that means that this is the longer leg. So a tip that I want you to write down is, if you are not originally given the length of the shorter side, you must find it first. So again, in this problem, I was given the length of the longer leg since it's across from the 60. So I need to come up with that formula that relates the longer leg to the shorter leg. So I know that the longer leg is equal to the shorter leg times the square root of 3. So I'm going to put in the values that I know. I know that the longer leg is 15. We're calling the shorter leg A times the square root of 3. So now I just want to get A by itself. So I'm going to divide by the square root of 3. So I end up with A equals 15 times the square root of 3. Knowing that we cannot leave a square root in the denominator, I'm going to multiply by the square root of 3 over the square root of 3. So I end up with 15 square root of 3 over 3. And then finally, I just want to reduce this fraction right here. So 15 divided by 3 is 5. So the short side is 5 square root of 3. So now we're on to the hypotenuse. I need to find the hypotenuse by taking the shorter side times 2. So the hypotenuse we're calling side B is 2 times the short side, which we now know is 5 square root of 3. So just to simplify that, we would end up with 2 times 5 is 10. So then the hypotenuse is 10 square root of 3. So we have 5 square root of 3 for the short side, which is A, and 10 square root of 3, which is the hypotenuse, which is what they are calling B. And just one more time to reiterate, always start with finding the shorter side first if you're not originally given it, because you have to have the short side in order to find the hypotenuse, since the hypotenuse is 2 times the short side. And now finally, example number 6. A kite is attached to a 100-foot string as shown in the diagram. So that 100-foot string would actually be the hypotenuse of the right triangle that is formed. How far above the ground is the kite when the string forms the given angle? So it's asking for how far above the ground it is, so we would be looking for this length right here. So in part A, it says, what if the measure of angle 1 is 45 degrees? If it's 45 here, it'd be 45 there, so I'd have a 45, 45, 90. So I'm going to think back to my formula. I know that the hypotenuse is the leg times the square root of 2. It's the leg that I'm looking for. So I'm going to put 100 in for the hypotenuse, x in for the leg, and then I'm going to multiply by the square root of 2. When I divide by the square root of 2, I would end up with x equals 100 divided by the square root of 2. Now, thinking about the logic of our answer, this is a story problem. It would not make sense to change this into simple radical form by getting the square root of 2 off the denominator, because we wouldn't answer a problem with the square root in it. So I'm just going to take 100 divided by the square root of 2 in my calculator to get a decimal approximation. So I end up with approximately 70.7 feet, and that would be the length of how far off the ground the kite is if the angle was 45 degrees. Moving on to part B, now they're saying, what if the measure of angle 1 is 30 degrees? So if this is 30 and this is 90, that means that this is 60. So I have a 30, 60, 90. So notice that the 30 degrees is here, and the length that I want is the short side. And I know that the hypotenuse is 2 times the short side. And it's the hypotenuse that I have, so all I end up doing for this problem is dividing by 2, so the short side would be 50 feet. So in this case, I don't have to do any rounding, and I know it would be exactly 50 feet off the ground. So that's it for this section. We will do lots and lots of practice with this, because I know this is something that people struggle with. So if this was confusing to you, just know that we'll take our time with it as we work through it in class. And as always, jot down anything you didn't understand that we can cover in class so we can clarify it before we move on. And we'll see you then.